next problem will be Roman to integer, and we have a longer uh, problem statement this time, so we will go step by step. So first, Roman numerals are represented by 7 different symbols, and so we have I, V, X, L, C, D, and M, and all of the symbols have a different value. So for example, C has the value of 100, X has a value of 10, and I has a value of 1. And this will be a good candidate. This mapping will be a good candidate for a hash map, because a hash map we will have key to value mapping, so we can have a symbol to value mapping in our hash map. Now for as we went to we can also combine different symbols. So for example, we have two i's which equal to 2, because one I equals to 1. You will have 1 plus 1 equal to 2. Then a more complex, you can say, example would be a combination of more different several few different symbols. So for example, we have x and two i's, which will equal to x plus I plus I. We know that x mapping is 10, so we'll have 10 plus 1 plus 1, which equals 12. Now, the number 27 can be written as XXVII, and we can split it again in the same approach. We have two x's. This is 10 plus 10, and v has the value of 5, so it will be 5, and then we will have again 1 and 1. So this is 20, and then with 5, 25, 26, 27. So the result will be 27. Now, Roman numerals are usually written largest to smallest from left to right. As you can see here, for example, the x has the highest value mapping, so it's put as the first character, and then as we move left to right, the symbols value are starting to decrease. However, there's few exceptions. The numeral for 4 is not the 4 i's. The maximum that we can use, continuous symbols that we can use is 3. So you can have 3 i's, but not 4. To present the number 4, we use a different approach. We use subtraction. So we have this representation, and this is the explanation, because the 1 is before the 5. We subtract it to make it 4. So v is equal to 5, and if we put a lesser denomination, you can say lesser value symbol before the one that has a larger value, we will subtract. So this was 5 and this is 1, so it will equal to 4. The same principle also applies to 9, which is written as ix, because x is equal to 10 and I is like a smaller value symbol. We will decrement it 10 by 1 and we will get 9. There are 6 instances where subtraction is used. I can be placed before v and x, so it cannot be placed before the symbols that have a larger value than 10. And we can, using these combination, we can, as we saw, we can get 4 and 9. X can be placed before L and C to make 40 and 90. So for example, if we have XC, C is 100. So if we put X, that means we will subtract 10 from 100 to get 90. And C can be placed before D and M to make 400 and 900. So if we have CM, we know that M maps to 1000, so we will subtract 100 from 1000 and we will get 900. Those are basically our rules, and are also good candidate for a different hash map that will serve as our rule engine, so we can check if we have a valid subtraction. Because as you saw, there are some rules. For example, we cannot apply I to a symbol L or symbol C. This is invalid. So if we have IL, this is invalid. It's not that this converts to 49, because we are decrementing 1 from 50, which is the mapping value from L. It's not the case. Now we will go through some examples. As you can see, we have, let's just clean the window. We have the first example is straightforward, just three i's, which equals to 3. Then we have more complex. L mapping is 50, V mapping is 5, and we have one I, which is basically 1. And then we'll just map this. So we have L, it will be 50 plus V, which is 5, and then plus 1 plus 1 plus 1, which is equal to 58. Okay, now to a more complex example, we have this input string. So we will have 1000, which is M. Then we have a C, but after it we have a M. So we have CM, and this is a valid subtraction. So we use C to decrement to get 900 basically. So it will be 1000 minus 100. This is the value for M, this is value for C, and it will go to 900. So we will add 900 to the whole sum. Next we have X, but after that we have C. So XC is a valid subtraction. It's 100 minus 10, which is 90. So we will be adding 90. And after that, we have an I, but after it, we have a V. And we also know that from examples, I and V equal to 4, because V is 5 and we decrement, we subtract 1 because I value is 1 to get 4. And this will result to basically to 1,994, which is actually the result that we got through here. Now to the constraints, the maximum length of the string will be 15, and we are only given a string that contains the valid Roman literals, so we cannot get I don't know, K, which doesn't represent anything. And it's also guaranteed that S is a valid Roman numeral in the range from 1 to 3,999, which is the maximum that we can do. Why is the maximum? Because as we said, we cannot have more than 3 symbols in a row. So the maximum that we could get is, for example, 4 M's, which is 4 times 1000, which is equal to 4 4000s, but we cannot have this, so the maximum is the 3,999. And now we will see how can we extract the formula to calculate Roman numbers from strings. Here I copied our mapping and also the valid subtractions, and we will do things differently right now for this example, because it will be easier for us to map it to code. First, we will have a previous value, which will be just set to an empty character in the initial declaration. And we will have an iterator that goes through the string, traversing the string from the beginning to end. And each time we will just add the value that the current symbol that the pointer is pointing to maps to. So, for example, we set I to 0, and our first value is M. So M maps to 1000. So we will just add 1000. And we will set M as our previous character. Now we will go to C, and we will just add it. We will not look ahead and see what we have next. We will just add it to our total value. This is our total result, which is just the integer representation of the Roman representation string. And as we said, we will just add the value of C, which is 100. And after we've done that, we will put we will overwrite the prev to C. We will move next to the to the next iterate to the next letter in the input string. We have M, which, as we know, maps to 1000. So we will just add 1000. But we also know that the previous character was C. So each time in each iteration, we will have a checking that checks if the previous character and the current character form a value subtraction given to us by these rules. So we have a previous character C and we have a current character M. So we have a C-M combination, which is a value subtraction. And in that case, we will subtract the value from our previous character. So we will subtract C 2 times. So that means 2 times, so 2 times 100, because C maps to 100. Why do we do it 2 times? First, we want to reverse the effect that we had because we added the C without looking ahead to see if it's a valid subtraction. So this is the effect. One of these two 100s will cancel out this as an effect to the total sum. And the second 100, we want to decrement from the value of the current character, in this case 1000, to get 900, because CM equals to 900. So we will just do the 2 times 100, and we will place M as our next character. Next, we will go to the next character, which is X, and we will just add. As always, we just add the value, which is 10, and we know that MX is not a valid subtraction. This is our previous character, this is our current character. This is not valid subtraction based on our rules. So we just move to the next character. And next character is C, and so we add just the value of the C, which is 100, but our previous character was X. So we have XC, and X can be placed before C. So this will be a valid subtraction, which equals to 19, by the way. So what we will do, we will basically decrement 2 times the effect of the previous character, which is 10. First time to cancel out this, and second time to actually subtract from the current character value, which is C. This is C. Next, we will move to the next character. We will place prev as C, and our current next character is I. So we will just add 1, and CI is the next combination. If we use the previous value of C and the current value of the character, which is I, so CI, and this is not valid subtraction, so we just move to our last character, which is V, and we add V because its value, which is 5, and we have our previous value was I, so we will have IV, which is a valid subtraction because I can be placed between before V and X, and in this example we have a V. So we will subtract 2 times the previous value, which is I, and the value mapping is 1. And so what we will have, we will first cancel out this with this, leaving it to only 100. Then we will cancel out this and leaving this to 10. We will cancel out this, leaving this to 1. So we will have 1,000, 2,000, but then 2,000 minus 100, which is equal to 1,900. Then we will add 100 minus 10, which is 90, and then we will have 5 minus 1, which is 4. And if we add all of this, we will get 1,994, which is the Roman representation of the Roman literal that we got as an input. Now let's code up the solution in Java programming language. First, we will declare the valid subtraction hash map, which corresponds to the rule engine, you can call it, that we are given by the problem statement. For a character, a key in the hash map, we can get the valid symbols that key can form a valid subtraction. So, for example, X can form a valid subtraction with symbols L and C. Next, we create another hash map that will map a character to an integer, basically just mapping the symbol to its value. For example, for L, we have the corresponding value of 50, and we will call it Roman to int map. We will declare our number and set it to 0. This will be our final result after adding the values of all the symbols that we have in the input string, and we will also declare the previous character and set it to null. We will traverse our input string, and each time getting the current symbol at the current index that we are at. We will add the value that corresponds to that symbol by using our Roman to int map to get the corresponding value. And now to the interesting part, we will first check if our previous character is not null, it's a valid character, and then if it can form a valid subtraction. So some characters cannot form. For example, we cannot have M before something else to form a valid subtraction. So let's say we have an X, and we'll get true for the contains key because our valid subtraction map contains that key. But to be sure that it's a valid subtraction, we also have to check for the current symbol that it's part of the set in the valid subtraction map. So for example, if it's an L, we know that X maps to the hash set of L and C, and with them it forms a valid subtraction. And if that's the case, we will first we will subtract the effect of the previous character 2 times. Once because we have already added it, so we have to cancel that out, and the second time because it's a valid subtraction, we have to remove the value from the current character. So for example, if we have X and L, we have already added L, which has a value of 50, so we have to decrement it by 10. That's why we are decrementing twice the previous character, which in this case is X. We will then set the previous character to the current character. So in the next iteration, we have a valid previous character, and we will return the number as our final result. As you can see, we have a limited size hash map, so that leads us to a constant space complexity, and we are only iterating over the string, which leads us to a linear time complexity proportional to the length of the string.